In 1940, a machine built in secret in the English countryside cracked one of the most complex codes ever devised. That machine, built to win a war, eventually became the thing that is now reshaping every job, every market, and every industry on Earth. This is how that happened. Nazi Germany had a problem, and they thought they'd already solved it. They needed to communicate. Troop movements, U-boat positions, air raid plans, all of it had to travel by radio, which meant the Allies could hear every word. So Germany built a machine called Enigma. Enigma scrambled every letter of every message using a system so complex, the number of possible settings ran into the quintillions. German commanders were certain it was unbreakable. They were so certain. They used it for everything. That certainty was their first mistake. Britain knew the messages were out there. They could hear them. They just couldn't read them. So they gathered the best mathematical minds in the country at a Victorian estate called Bletchley Park. Mathematicians, linguists, chess champions, crossword experts. Over 10,000 people at its peak, all working on one problem. And the problem was brutal. Germany changed Enigma's settings every single day at midnight. That meant whatever they cracked yesterday was useless today. Every morning, they started from nothing. Here's something most people don't know. The British didn't crack Enigma first. A Polish mathematician named Marian Rejewski did, in 1932. Using pure mathematical deduction and a set of operating manuals leaked by French intelligence, he reconstructed how Enigma worked without ever seeing the machine itself. In 1939, weeks before Germany invaded Poland, Rejewski and his team handed everything to Britain and France. Every method, every breakthrough. Without that handoff, Bletchley Park would have spent years on what Rejewski had already solved. Alan Turing arrived at Bletchley Park in 1939. His job, figure out how to crack Enigma every single day before midnight, for as long as the war lasted. Turing spotted something. German operators were lazy. They started messages with predictable phrases. Weather reports, routine updates, always the same words. Turing called these cribs known pieces of plaintext that had to appear somewhere in the encrypted message. He built a machine that exploited this. The bomb, named after a Polish machine Rejewski had built years earlier, worked by testing thousands of Enigma settings against a known crib simultaneously, not one at a time, all at once. Over 200 bombing machines were eventually built. Together, they could crack the day's Enigma settings in hours, sometimes minutes. The war turned. But there was a second cipher, even more secret, used only by the German High Command for their most sensitive communications. The bombie couldn't touch it, so they built something else entirely. Tommy Flowers, an engineer from the General Post Office, wired together 1,500 vacuum tubes into a machine that had never existed before. A machine that could be reprogrammed, that could change its instructions, that could solve different problems on different days. Colossus, the world's first programmable electronic digital computer. It was ready in December 1943. An upgraded version, Colossus Mark II, came online in June 1944, just in time for D-Day. And when the war ended, Churchill ordered every single one destroyed. The 10 machines built, the blueprints, all of it, classified for nearly 60 years. The first computer, and almost nobody knew it existed. Alan Turing helped win the war. Then Britain destroyed him for who he was. In 1952, the British government prosecuted Turing for homosexuality. The sentence, court-ordered hormone injections as punishment. He died in 1954. He was 41 years old. The circumstances were never fully resolved. In 1950, 2 years before his prosecution, Turing had published a paper. It opened with a question: can machines think? He didn't get philosophical. He proposed a test. If a machine could hold a conversation that a human couldn't tell apart from talking to another human, then the question of whether it was really thinking became irrelevant. He predicted machines would pass this test within 50 years. He was almost right. 6 years after that paper, a mathematician named John McCarthy invited a small group of scientists to spend a summer at Dartmouth College in New Hampshire. Their proposal: what if machines could learn, reason, use language, form abstract ideas? McCarthy called it artificial intelligence, a name he chose deliberately because it belonged to no existing discipline and no one could own it. The workshop produced no breakthrough, but it did something more important. It gave the field a name, a founding community, and a shared goal, and the timing was perfect. Then, on October 4th, 1957, everything changed. The Soviet Union put a satellite in orbit, Sputnik. The United States had no idea it was coming, and if the Soviets could put a satellite in space, they could put a nuclear warhead anywhere on Earth. President Eisenhower created DARPA, a military research agency whose only job was to fund dangerous, transformative ideas before the enemy could. DARPA poured money into computing, into AI research, into something else, a network. The American military's communications were centralized. One nuclear strike could cut the whole thing, so DARPA funded a network with no center, no single point of failure. They called it ARPANET. On October 29, 1969, the first message was sent. It was supposed to say, login. The system crashed after 2 letters. The first word ever transmitted across what would become the internet was LO. The AI researchers had made enormous promises, human-level machine intelligence. Within a decade, they said it through the 50s, through the 60s, through the early 70s. Then the decade passed, and nothing worked outside a lab. In 1973, a British government review declared AI had failed. Funding collapsed, labs closed, researchers left. A decade later, companies tried again, this time with expert systems, programs that encoded human knowledge as rules. They worked in narrow settings, but they couldn't learn. They couldn't adapt. The market collapsed again in '87, 2 winters. The field nearly died twice, but a small group kept working. One researcher didn't leave. Geoffrey Hinton had spent years studying neural networks, systems loosely modeled on how the human brain connects. The idea was decades old, but no one had figured out how to train them efficiently. In 1986, Hinton and 2 colleagues published the answer: backpropagation. After a neural network made a prediction, you could mathematically trace exactly how wrong each internal connection was and fix it. Do that millions of times across thousands of examples, and the network learned. The algorithm worked. The computers of the 1980s were just too slow and the data too scarce for it to matter yet. Hinton kept going. The world just had to catch up. Then the internet went public. In 1991, Tim Berners-Lee opened the World Wide Web to the world. What followed was the largest accidental data generation project in human history. Images, text, video, every search query, every purchase, every message. By 2010, over 1.2 million terabytes of data. By 2020, 2.5 quintillion bytes generated every single day. This data, without anyone planning it, was exactly what neural networks had always needed. And one more thing fell into place. Graphics processors, GPU chips built to render video games, turned out to be perfectly suited to running neural networks. Fast, parallel, cheap enough to buy commercially. The algorithm was ready. The data was ready. The hardware was ready. In 2012, Geoffrey Hinton's lab entered the world's hardest image recognition competition, the ImageNet Challenge. Every year, the best teams in the world competed to identify 1.2 million images correctly. The previous year's best entry had an error rate of 26%. Teams improved by about 1 or 2 points per year. Hinton's team, using a deep neural network called AlexNet, running on 2 GPUs, had an error rate of 15.3%, an 11-point gap in 1 year against every team in the world. This wasn't an improvement. This was a rupture. Within months, every major AI lab pivoted to deep learning. Google, Facebook, Microsoft, Baidu. One of Hinton's students, Ilya Sutskever, would go on to co-found OpenAI. The age of deep learning had begun. Deep learning could recognize images, But language was different. Old language models processed text one word at a time, left to right, slow, and they couldn't connect words that appeared far apart in a sentence. In 2017, 8 researchers at Google published a paper called "Attention is All You Need." Their solution? Instead of reading one word at a time, what if every word in a sentence could simultaneously pay attention to every other word, weighing how relevant each one was? They called it the transformer. It was faster, it could scale. More data and more computing power made it proportionally better. And when you built a language model on top of it, something happened that nobody fully expected. The model didn't just learn grammar, it learned to reason. November 30th, 2022, OpenAI released ChatGPT to the public, a free preview, a conversational AI that could write essays, answer questions, debug code, translate languages, hold a conversation, and sound almost human. Within 5 days, 1 million users. Within 2 months, 100 million. That's the fastest any consumer application had ever grown in history. TikTok took 9 months. Instagram took 2.5 years. The responses came immediately. Google launched Gemini. Microsoft embedded AI into every Office product. Meta launched Meta AI. And 7 former OpenAI researchers who had leftover concerns about safety founded a company called Anthropic and released an AI called Claude. 100 million people had started using AI. And the world's financial markets noticed. Think about what just happened. Nazi Germany encrypted its communications with a machine they believed was unbreakable. That certainty forced the Allies to build the first programmable computer. The man who built its mathematical foundation asked whether machines could think. A group of scientists answered that question by naming a new field. Cold War fear funded the network those ideas traveled on. 2 decades of failure drove the science underground. Where one stubborn researcher kept going, the internet generated the data. The GPUs found the compute, and eventually, 80 years after Bletchley Park, the question Turing asked became something you can have a conversation with. Nvidia is now worth more than the economy of most countries. 100,000 jobs changed in 1 year, and it all traces back to a cipher machine in 1940. History doesn't move in straight lines, it moves in chains, and sometimes a single link you never even noticed holds everything together. If you think you know 2 events that are secretly connected, drop them in the comments. The most liked comment gets the next video. If this one surprised you, like and subscribe. There are a lot more chains to trace.